Hi everyone! Today we are going to continue simplifying radicals, but we're also going to learn something new called the imaginary unit and complex numbers. So let's give a little background first. It says certain quadratic equations have negative square roots in their solutions. The value, which means that the value under the radical sign is negative. So it would look something like this, like negative square root negative 5. That's an example, okay? These square roots are called imaginary numbers because the roots are referred to as complex roots. These complex roots are expressed in the form a plus or minus bi, where a is the real part and b is the imaginary. Bi is the imaginary, and that kind of makes sense. Think of like that I right there. That I stands for imaginary, okay? So this is the real part and that's the imaginary part. Now, it says the imaginary unit is I equals the square root of negative 1. So anytime you guys see the square root of negative 1, you can replace that with an I. Or you could say I squared equals negative 1, which if we think about that, that is the same thing as this right here. If I square this term to get rid of that square root, whatever you do to one side, you have to the other. So I would square this I squared. So I would get I squared equals, that square root would be gone, would be negative 1. Okay, so you can kind of remember one or the other and then work, use some math skills from there, or you can just memorize both of them. Alrighty, so over here, we've got the equation y equals x squared plus 4x plus 5. It says the graph of this quadratic function shows that there are no real roots, or zeros / solutions even. So remember, we talked about solutions for a quadratic function are where they cross the x-axis, but this function does not cross the x-axis or even touch it, right? So because the graph does not cross the x-axis, we don't have any real roots here, okay? Such a graph tells us that the roots of the equation are complex and will appear in the form a plus or minus bi. So when we see a graph like this that does not touch the x-axis or cross it, we say that it has imaginary solutions, okay? There's no real solutions there. All right, let's first just practice simplifying these expressions in terms of I. So think of this as the square root of negative 1 times the square root of 18. Okay, we've already practiced simplifying things like the square root of 18. So all we have now is this negative 1. Negative 1 times 18 is negative 18, right? So all I did was rewrite the problem. Well, we know that the square root of negative 1 is I from up above. That's what it told us, right? Now we can simplify the square root of 18. 9 times 2 gives me 18, right? The square root of 9 is 3, so I'm going to take that out. I have the I term, and I cannot take the square root of 2, so he stays underneath. So my answer is 3i square root of 2. You always want to make sure that I is outside of the radical. That's the key thing there. And correct math notation is putting the number of what you take out of the square root to go out in front of the I. Okay, that's proper math notation. You'll get used to it with more practice. All right, number 2, square root of negative 50, x squared times y squared. So I'm going to write this into each of their own terms. And what I mean by that is I'm going to take the square root of negative 1, the square root of 50, times the square root of x squared times the square root of y squared. So all I did was rewrite this as 4 separate terms, negative 1, 50, x squared, and y squared. Okay, and then I'm going to focus simplifying on each individual piece here. So the square root of negative 1 is I, we know that. Square root of 50, I'm going to break that down as 25 times 2, right? 25 times 2 gives you 50. Whenever I have something squared and the square root is being taken of it, that goes away. So this just becomes x. Same thing with this y squared. The square root of y squared is just y. Okay? Alrighty. Now I gotta simplify this a little further. So I have I, x, y all on the outside. The square root of 25 is 5. And I cannot take the square root of 2, so he will have to stay under the radical. So 5i xy times the square root of 2. Alrighty. Number 3, square root of negative 25, which is square root of negative 1 times the square root of 25. Square root of negative 1 is I, and the square root of 25 is 5. There's nothing left under the radical because 25 is a perfect square, so I'm done. Number 4. All right, now we don't have a radical, but notice I can think of this as like negative 2x times 7x, okay? You would multiply the negative 2 and the 7 and get negative 14. Negative times positive is negative. And like if these were x's, you would say x times x is x squared. Well, same idea, except these are i's. I times I is I squared. Now, anytime we see I squared, we know that I squared equals negative 1 from up above. So I'm going to substitute a negative 1 in for that I squared. So I have negative 14 times negative 1. Two negatives make a positive, so this actually equals positive 14. Okay? All right, number 5. I'm going to move this down just a little bit for some more room. All right, so I am doing the square root of negative 10 times the square root of negative 15. So I'm going to just focus on doing the square root of negative 10 first and simplifying that guy. So this gives me square root of negative 1 times the square root of 10. Alrighty. And I can't simplify, well, I can't simplify the square root of 10. So this is just I square root of 10 because we know the square root of negative 1 is I, right? All right, the square root of negative 15. You can say the square root of negative 1 times the square root of 15. And again, you cannot simplify the square root of 15. Square root of negative 1 is I, so we have I times the square root of 15. All right, remember, we're multiplying these two together, so I'm going to take these and multiply them together. So I have I squared root of 10 times I squared root of 15. All right, I times I is I squared. 10 times 15 is 150. So I have I squared times square root of 150. And honestly, you guys right off the bat could have like done that piece right there. So, well, actually, no. Whenever you have a negative, you guys cannot do that. When you have negatives under the radical, you guys cannot multiply these two numbers together because you'll forget about this I squared term. So do not multiply these together right away, okay? All right. I squared is negative 1, right? And then 150, we have 25 times 6. Square root of 25 is 5. So this is actually negative 5 because negative 1 times 5 is negative 5. And I can't do anything with the 6. Okay, notice if you multiply this negative 10 by negative 15 first, you'll get the square root of 150, and then you'll forget about that negative because you won't have that. All right, so just make sure when you have this, I would simplify each individual radical first and then multiply them, which I know is just a tad different of when we were just talking about multiplying your radicals, so be careful. All right, number 6. So these are just operations with the complex numbers. We have a real and an imaginary term. That's why this is a complex number, and same thing over here. And you're going to combine your real numbers and combine your imaginary numbers. So kind of similar to just combining like terms here. So I'm first going to distribute this negative though, because I don't want to forget about him. So 8 plus 6i minus 2 minus 3i. And then I'm just going to combine my like terms. 8 minus 2 is 6. 6i minus 3i is positive 3i. And I'm done. Okay, on to the back. All right, number 7. So here I am adding. All right, I've got, and because I'm adding, I'm just going to go ahead and combine my like terms. 5 plus 4 is 9. Negative 2 plus 4i is positive 2. And then I have the I after those. Okay, number 8, we are multiplying. Okay, here we're just going to FOIL. 3 times 4 is 12. 3 times 6i is 18i. Negative 5i times 4 is negative 20i. And negative 5i times 6i is negative 30i squared, because I did I times I. All right, so then now I have 12 minus 2i, 18i minus 20i is negative 2i, minus 30, but I squared equals negative 1, so I'm going to substitute that negative 1 in for that I squared right there. Okay? So then now I've got 12 minus 2i, negative 30 times negative 1 is positive 30. And then I have 12 plus 30 that are like terms, so that becomes 42 minus 2i. Okay? Whoops, sorry. All right, number 9. Now pay attention here. If you are in regular Algebra 2, you guys can do this on your calculator, but if you are in honors, you will have to do this by hand. So for those of you that are in regular, this is how we would type this in. Hit alpha y equals, hit enter, so that gives you your fraction. You're going to hit 3, and to type in I, it's actually down here, right on top of that little dot, okay? So we're going to hit second and this little dot, and you guys will see we got 3i in the numerator now, okay? Ooh, kind of got a bad glare there. There we go. All right, over 2 plus 4, second, that little dot I. All right, and then just hit enter. 3 over 5 plus 3/10 I. 5 plus 3/10 I. Okay, so regular, you're doing that on the calculator. So that's for like the division. So this is division, clearly. Okay, we did 3i divided by 2 plus 4i. Okay, honors, you're going to do this by hand. Now, if you're in regular Algebra 2, you guys can go ahead and skip this part of the video and go straight to number 10. If you're honors, go ahead and stay on and listen to this piece right here. So to start this off, we have 3i divided by 2 plus 4i. Okay, now I'm going to multiply this denominator by and the numerator by the complex conjugate, which is 2 minus 4i. Okay, notice the only thing that's changed was the imaginary number term. The reason why we're going to do this is kind of think of this like the factoring of a difference of 2 squares almost. And when I FOIL that out, that middle term is going to go away. Okay, and we're going to do this to the numerator as well. So then it looks like technically I'm doing, I'm multiplying this guy by 1, because 2 minus 4i divided by 2 minus 4i would just be 1. Okay, remember, we're being mathematicians, not magicians. All right, so then from here, you're going to FOIL this out. So 3i times 2 is 6i, and 3i times negative 4i is negative 12i squared. All over, 2 times 2 is 4. 2 times negative 4i is negative 8i. 4i times 2 is 8i. And 4i times negative 4i is negative 16i squared. Alrighty, from here, we gotta simplify a little more. So remember, I squared is really negative 1. Okay, so this becomes 6i plus 12 all over. Notice the negative 8i and positive 8i cancel each other out. Remember, I squared is just negative 1. So this is 4, and that negative 16 times negative 1 is positive 16. So 4 plus 16. That would give us 6i plus 12 over 20. And notice that we can reduce all of these numbers by 2. But when we do that, we get 3i plus 6 over 10, right? Yeah, when we divide those all by 2, which then gives us the 3i over 10 plus 6 over 10. That can reduce even more, which is, divide those both by 2 is 3/5. Sorry. Ooh. I think there for a second. Okay, which is the same answer up here, right? Okay, so either you guys can write it like that, or you guys can switch the real and the imaginary term. I'd accept either. Okay. All right, number 10, regular. Make sure you're doing this on your calculator. So alpha y equals, we've got 5 divided by 2 second dot. That gives you the 2i. So this is negative 5 over 2i. Okay. So again, regular on calc, honors by hand. All right, so honors kids, we've got 5 over 2i, and again, we're going to just change the imaginary term. So we're going to multiply by negative 2i by both the numerator and denominator, because then that means we're really multiplying by 1 here, okay? So we get negative 10i all over negative 4i squared, right? 2 negatives make a positive, so this is really 10i over 4i squared. But we know that I squared is negative 1, right? So this is really 10i over negative 4. 4 times negative 1 is negative 4, right? Well, then that even reduces. I can divide those both by 2, so I get 5i over negative 2, which is the same thing as negative 5 over 2. So, okay? Alrighty. So that's operations with complex numbers. Now, the last thing we're going to do is graph here. Okay? Complex numbers in the form a plus bi can be represented geometrically as points in the complex plane. The complex plane is a regular grid, or a rectangular grid, sorry, similar to the Cartesian plane, meaning like xy, with the x-axis representing the horizontal axis, representing the real part, which is a. So the horizontal axis, that's your x-axis. These are where the real numbers go of a complex number, and the vertical axis represents the imaginary part, which is the bi of a complex number. So the vertical axis, which is your y-axis, this is your imaginary part of your complex number. So this is like the bi, this is like the a term, okay? The point AB on the complex plane represents the complex number a plus bi. So number 11 says graph 2 plus 3i and negative 3 minus 4i on the complex plane given below. So this coordinate point, it's just the a and the b term. Well, my a term is 2 and my b term is 3. Okay? And then this coordinate point, my a term is negative 3 and my b term is negative 4. So you're going to graph this just like you would an xy value. Okay? So let's do 2, 3 first. So I'm going to go 2 to the right, up 3. And that is your 2 plus 3i. Okay? Negative 3 minus 4i, that will be negative 3 minus 4i. Be right there. So negative 3 minus 4i. I'm labeling these points so you guys know which one was which. Okay? So just remember real, imaginary, and then you're just going to graph it like an xy coordinate basically. Okay? All right, go ahead and get started on your homework, guys.